I wanted to find out what happens if I use GPT-4 to create a fully synthetic dataset and I use that dataset to fine-tune our ChatGPT 3.5 model. Will we get like a super ChatGPT or will it not make any difference at all? Let's find out. I created this workflow you can see here on how we are gonna do this. So we're gonna use GPT-4 to create a synthetic dataset. For this we will use some Python scripts that is, just makes it automatic. Then we're gonna take this synthetic dataset we create with GPT-4 and use it to fine-tune a ChatGPT 3.5 turbo model. And we're gonna take our created fine-tuned model and do some benchmark tests to see if we can see any difference using vanilla ChatGPT versus GPT-4 and versus our fine-tuned model, and see where this model kind of lands after we had fine-tuned it on maybe 100, 200 examples of the GPT-4 synthetic data set. So I think that's pretty much it. It should be pretty simple to follow, so let's see how this turns out. The first thing I wanted to do was find out what kind of data set do I want GPT-4 to create for me. So I settled on a mixture of riddles, math problems, logical problems, because I think that's easy to test and do like a benchmark between the original ChatGPT and our new fine-tuned model, right? So you can see an example of a problem here. Emily is a 27-year-old woman from Brazil. She's standing in front of an iconic structure in India taking pictures. The silhouette of this structure reminds her of a character from a classic video game she used to play during her school days. What is the primary obstacle or enemy that this video game character faces? So you can see here, we kind of want to follow these kind of step-by-step instructions for every problem because we want that baked into our fine-tuned model, right? So we have some assignments, we have the response, right? Identifying the structure, so associating the structure, determining the character. Yeah, that's the kind of the problems that need to be solved. And here it's gonna try to solve them. So the iconic structure in India is frequently photographed by tourists are Taj Mahal. The character or the doomed silhouette of the Taj Mahal might remind someone of the character Pac-Man, considering the character's shape. So I checked that out. Yeah, that's pretty accurate. I'm gonna put a picture of it here. So determining the character's primary obstacle enemy in Pac-Man, the primary enemies are ghosts like Blinky, Pinky, Inky, and Clyde. So the answer is ghost. So these are kind of it's not that difficult, but I think these problems kind of fit well because we can use this step-by-step chain of thought principle here to solve this. So let me just show you another example of a problem we want to solve too. Okay, so here you can see we have a different problem. This is more of a logical problem. I'm not going to read this out. You can pause if you want to read it. But again, you can see we kind of follow this same procedure here. We find problems that need to be solved. We're going to solve them step by step. And yeah, you can see with this approach, you'll be able to find exactly which bottle is poison in just 24 hours using only 10 prisoners. So this is kind of the sequence we want for our dataset. And to create this, I'm not going to sit in GPT-4 and type in each problem and ask for a new problem. So we're going to head over here and use Python to create these problems and datasets. So you can see I created this Python script here. It's pretty simple. It's pretty straightforward. We have an open and save file function. We have the ChatGPT function because we need that. We have set that to GPT-4. So we use the 0613 model to follow system prompts better. And then we have a loop here, so we can set the number of loops we want to run through. So this is just gonna create a text file of the dataset, but in the other similar script, we're gonna create the JSON file. I'm gonna show you that later. But basically, this is a very simple script. It just, like I said, uses a loop. So it's gonna open one file, it's gonna use ChatGPT on that file, and it's gonna take that results into our new prompt, and it's gonna return a response. And we're gonna save them like with different timestamps. So you can see here we have a prompt that is called, or we have a file that's called problems.txt. So this is how we're gonna create our problem, because we want to create one problem and then we want to solve it in the next step. So you can see your task is to create one problem that involves a complex problem that can only be solved in a step-by-step way. And then I'm gonna provide the examples like we looked at now. So we have an example 1 here, and we have how we solved it. We have a new example, right? Here is the bottle example, the poison bottles, and how we solved that. And we have a third example. So these are more of a different problem. All roses are flowers, no flowers are trees. So these are more like a linguistic problem. And you can see we have a solution for that too. So final answer, given the analysis, the correct conclusion is B, C, and E, right? And then create a similar problem to the examples above, just the problem. Because we don't want the answers here, we just want the problem. And we're gonna use that problem into this new prompt we have here. Here are some examples the users have provided. So I'm gonna repeat that once or twice maybe, I think. And then I'm gonna do problem, and I'm gonna do a placeholder here. So the result from this prompt is gonna be fed automatically into here. So your task is to complete the assignments in order. And again, you can see we repeat the assignments here. Like this. So hopefully that will give us a very similar data set to this step here. So I think we're just gonna run this script, and we're gonna create 1 or 2 data sets in text files, and then we're gonna have a look at them before we look at how we do them over in a JSON L form that we need for fine-tuning. So let's just set the number of loops to 2, right? That should be good. Let's save that. Let's save our file here and head over to the terminal, and we can just go Python, I think it was GPT-4 ft.py, right? Okay, so let's just let this run, create a couple of examples, and let's have a look at it. Okay, so now you can see we have saved 2 examples to this folder here. So let's just open one of these examples. So we go to responses, let's open this one. So here you can see now we have the input. So this is going to be our problem. So this is a new problem. GPT-4 created this problem here. This looks more like a riddle, or is it like a logical problem? I'm not going to read all of this, but if you want to, just hit pause. And then we get a response here. And you can see now we just go straight to the problem solving. Problems that needs to be considered. So here we get 4 steps. Yes, that's good. Let's solve this step by step. And then we attack each step, right? To try to solve this. So by elimination, the blacksmith's house. And we get a final answer. Perfect. That exactly, this is kind of the structure we want. Therefore, the treasure is most likely in the greenhouse. Perfect. So you can see, we can take a quick look at the other example too, right? So yeah, you can see the structure is pretty much the same. We get problems that needs to be solved. Let's solve it step by step. Final answer. Yes, I like this. So this means that we are actually ready to create this into a JSON-L form that we can use for fine-tuning. Let me quickly show you how we can do that. Okay, so we have basically exactly the same script. The only difference here is at the end here, we're gonna create a JSON object, right? So I'm not gonna go too deep into this, but if you want a deeper explanation, I might do a members video if someone asks for that. But it's basically just the same process, but we are gonna feed this into like this structured form here that we need to do a fine-tuning job. And that is basically it. So I think it's better if we just create one loop here and I'll show you the results, right? So let's save this as problems2 and go over here and just run this. Let's do this. Okay, so let this run and then we can take a look at the JSON output from this. Okay, so we saved an example as on JSON here. So let's just open that, responses, problems. So here you can see the structure. So we have messages, role, system content. So this is going to be our system prompt, right? I guess I didn't show that. So it's basically, you're an expert problem solver. You always think about the problem in a step-by-step way. Your background is a PhD in Harvard in solving problems using chain of thought, reasoning, and common sense. Okay, that's good. Then we have this structure. So this is the role user content. This is basically our input. So yeah, we have our problem here all the way down. Ooh, it's hard to see. But anyway, here is kind of our problem, right? And here is the response and the final answer. So this is the structure we need to create our fine-tuning model. And this is fully automatic now, so this just depends on how many loops we set here. So if we set, I'm gonna do 150 today, I think. It's gonna be a bit expensive, but yeah, we're gonna measure that too. So if I do 150 loops, we will get 150 of these examples with different problems and solutions, right? So I think that is basically what we are gonna do next now. So yeah, interesting. Okay, so before we run the 150 examples, I just wanted to monitor like what kind of price we are gonna pay for this. So you can see today is the first day of a new month, 1st of October. So we have only spent 40 cents so far. So let's see what kind of cost this is gonna be now, because we can get the cost for fine tuning and we can get the cost for the data set, right? So we have the full cost for the whole fine-tune model. So yeah, I think we are ready. So let's set the loops to, I think I'm gonna do 150. I'm kind of tempted to do 200, to be honest. Yeah, I think we're gonna do 200. I'm just gonna spend a bit of money on this, just for, yeah, the experiment, right? So yeah, I think we are ready to run 200 loops of this. My guess it's gonna be like maybe $30, 20 maybe. So yeah, let's find out. Okay, so let's head over to the terminal. Okay, looks good. I think I'm gonna put up a timer on this. So let's put it down here, just to see how long it takes to run 200 loops. So let's start this. Okay, let's do this. Move this over here. I think this is gonna take a while, so I'm just gonna do this and yeah, let this run. Okay, so I know I said 200, but I just had to stop it there because we spent 1 hour and almost 50 minutes on this. I got some other stuff to do, so I just had to stop it there. But let's take a look at what we have so far. Let's go into here. So this is 600 kilobytes. And yeah, here you can see our dataset now. 161 examples. So yeah, I'm happy with that. Now let's move on to our next step. And that is of course gonna be to actually train the model we just created all those examples for. So again, we have this code snippet here. I'm gonna upload this to my community GitHub. So if you want to get all this, I can also upload this example generator here. So you can create your own synthetic data if you want that. Yeah, just check out the membership and you will get access to the GitHub. I'm gonna leave a link in the description for that. But here you can see, here is our problems ft.jsonl. So I'm just gonna put that in here. That means that we can run this and we can upload all these examples to OpenAI for fine-tuning. We have a second script here that is just gonna take the file ID we get from this when we have uploaded the files and just create the job, and we're gonna select the model. So we're gonna do a GPT 3.5 turbo fine-tuned model. So yeah, basically we are ready here. We will also get the price of the fine-tuning. Okay, so I'm just gonna go to the terminal here. Let's run this. Perfect, so you can see file uploaded successfully with ID. Now we need to copy this file ID here. We can go back to our second model here, paste in our file ID, save that, and yeah, let's run it again. Perfect, fine-tuning job created successfully with ID. Okay, so now we can take a look at the new interface here. Let's zoom in a bit and we can reload this. So now you can see we are validating our files here. This is a new interface, so we can actually follow along how the fine-tuning job is done. We have something called epochs. So I think I'm gonna explain what that means. We have training loss. So let's take a quick look at exactly what those things mean. Okay, so in our case, we have 3 epochs, as you can see here. When fine-tuning an LLM model, what does epochs mean? In the context of training or fine-tuning a machine learning models like LLMs, epochs refer to one complete forward and backward pass of all training examples. Essentially, it represents the model having seen and learned from every sample in the training dataset once. So we have a forward pass, a loss computation, and a backward pass. So in the forward pass, the model makes predictions based on the input data. The difference loss between the model's predictions and the true label is computed, and the backward pass is the model adjusts its weights based on the loss using optimization algorithms like gradient descent, right? So that is how you can explain epochs. We can ask also about training loss. I think that's interesting too. What does training loss mean? So when fine-tuning an LLM model, what does training loss mean? I think we're just gonna go to a conclusion here. So in summary, training loss is a measure of discrepancy between a model's predictions and the actual data in the training set. It's a key indicator how well model is learning and can provide early warnings about potential issues like overfitting. So yeah, you can see overfitting is like if the training loss keeps decreasing, it means the model is learning and adapting to the training data. So that is what we are going to look out for here now. So you can see we started here on step 1. We have a training loss of 1.2. So hopefully when our model keeps training now or fine-tuning, this training loss will go down like it says here. If the training loss is very low, it indicates the model has fit the training data almost perfectly. However, this isn't always a good thing. If the model learns the training data too well, it might just be memorizing. It's a phenomenon known as overfitting. An overfitting model might perform poorly on new unseen data. Yeah, okay, that's interesting. So we're gonna monitor this now. So you can see now it dropped to 0.94. So we're just gonna keep this image up here and we're gonna monitor the training loss here. So hopefully it's gonna go down over time now. So let's just keep this screen up and see where we end up. Okay, so that was the fine-tuning job completed. As you can see here, we started on step 1. We had a 1.2 training loss. We ended up like halving that to 1.6. I'm no machine learning expert. I don't know exactly what these numbers mean. But yeah, you can see here on the metrics, we started on step 1, 1.2, we went up with 1.23, but at step 4.18, we were at 0.6. I think the lowest we had was 0.36. But like I said, I don't know exactly what this means, since I'm no machine learning expert. We trained the model on 370,000 tokens, almost. Let's take a look at the price here. So if we see for training the model, we only spent $3, but for creating this the dataset, we spent $32. So total of $35 for this model. It's not cheap, right? Remember, this was only 170 examples, I think. Let's say you need like 1,000, 2,000 synthetic data examples. It's gonna be quite expensive if you want to use the GPT-4 model. So yeah, but I think it's time now to actually do some simple benchmark test looking at the vanilla ChatGPT model 3.5 and our new fine-tuned model, if we can see any difference. So I think we're just gonna head over to ChatGPT and do some examples and evaluate our model. Okay, so this is the problem I wanna start with because I know this is not in the training data. This is a problem I've done many times on this channel. Yeah, we could just go through it. So Michael is a 31-year-old from America. He's at that really famous museum in France looking at his most famous painting. However, the artist who made his painting just makes Michael think of his favorite cartoon character from his childhood. What was the country of origin of the thing that the cartoon character usually holds in his hand? So what if we just run this now in ChatGPT 3.5 and let's see the result. So you can see I tried a bunch of times here, but we can't really get an answer. The usual sound would be 10 minutes specifically. It can't really answer it because it says, without more information about the cartoon character in the question, it's not possible to determine the country of origin of the object. So I went ahead. I wanted to show you like our model name is ends with SFK. So we're just gonna go to the playground here. We can select our model down here, SFK, right? Perfect. I just leave the temperature at 0.9. We just increase the length a bit here. And then we run the same problem here. So let's try to run this and see what kind of answer we get. Okay, so this is interesting. So you can see the artist who made the painting is Leonardo da Vinci. The most famous painting in the museum is likely Mona Lisa. Since the artist reminds him of the cartoon character, we will assume the character is likely Leonardo. Yes. The Teenage Mutant Ninja Turtle, named after Leonardo da Vinci. Wow, this is good, right? Now for the question about the country of origin. Generally all TMNT, including Leonardo, hold weapons. Leonardo is known for wielding 2 katanas, which are traditional Japanese swords. Therefore, the country of origin. Wow. Okay, this is looking quite good. So yeah, basically this is the same question. No, we can't get an answer here. It's hopeless. Huh. I'm actually a bit surprised. Wow. Okay. That was not many examples, but the kind of thing we learned the model here is to actually use this chain of thought, step-by-step way of thinking. And it's kind of baked into the model, so it doesn't have to go through every step here like in plain sight. It just knows it internally to do that for every problem. I think we need to find another problem to test this. So far, very impressed. Okay, so the next problem we have is this. We're gonna start on GPT-4 so we actually can have the answer. So I am in my garage. I found a small ball 2 centimeters in diameter and a cone with a hole in the top of 10 centimeters in diameter and a hole in the bottom of 5 centimeters. I bring the small ball and my cone into my office. In the office, I hold the cone in the air and I drop the ball into the cone. I then bring the cone to the post office, I put it in a big box and I send it to my friend in New York. Where is the small ball now? Explain each step with your reasoning. Okay, so here GPT-4 breaks down the sequence of events. You found the small ball, you also found a cone with a hole in the top and bottom. You bring them to your office, but you can also see this means that the ball can pass through this hole. Okay, so you bring them into your office, you hold the cone in the air and drop the ball into the cone. So the ball will pass straight through the cone and land on the floor on any surface below the cone. Yeah, you send the cone to the post office. The ball was not mentioned being put in a box, so it's left behind in your office. So the conclusion is the ball is still in your office. Okay, so yeah, that is of course the correct answer. As a human, you would know this, like if you know how the real world works. So let's try this on ChatGPT Vanilla. So here you can see we get a whole different answer. The ball is still inside the cone, which now is inside the big box you sent to your friend in New York. Let me explain what happened. So the big box with the cone inside was sent to New York. In your office, you held the cone in the air, dropped the small ball in the cone. When you drop the ball into the cone, it will have fallen through the top and eventually come to rest somewhere inside the cone. No, that's just wrong, right? That doesn't make any sense because we have those 2 big holes. So that is wrong. So let's try this now on our fine-tuned model. Okay, so this was interesting. This is somewhere between GPT-4 and ChatGPT 3.5 if you ask me. We get a nice step breakdown here. So you find a small ball. Yeah, we can read this. We refer to this as cone A. You bring the small ball and the cone to your office, holding the cone in the air, you drop the small ball to it. Due to gravity, ball will towards the bottom hole of cone A, passing through the cone. So that is key, right? It kind of understands that the ball will pass through the cone, whilst in here it didn't mention that at all. So we show some improvement here at least of reasoning. You put the cone A with the ball inside. Again, why? Why is it telling that when it just said it's passing through? I don't understand. And step 5 is what happens inside cone A. I thought that was interesting. The crucial thing to note here is cone A doesn't have a closed bottom. It only has a hole. Therefore, anything dropped into cone A will simply fall through the cone and out of the bottom hole. Thus, as soon you drop the ball into cone A, it falls through the bottom hole. When you send cone A to your friend in New York, you're basically sending an empty cone because the ball fell out as soon as you dropped the cone into your office. Yeah. Wow. But why does it set step 4 taking cone A with the ball inside to the post office? That was better contradicting itself, right? Therefore, the small ball is left behind in your office, possibly on the way to the post office. But it's not in the big box as it fell out. So it's a bit... So I said, give me your final answer. The small ball is not in the big box with cone A as it fell off the bottom hole as soon as you dropped it in. It either remains in your office or was left behind somewhere on the way to the post office. So it isn't quite sure here, but at least it's a big improvement over the vanilla. So I would place it somewhere in between GPT-4 and ChatGPT 3.5. So I'm kind of happy with the results. I think this kind of proves that, of course, we need a lot of more tests, right? But I think it proves some kind of improvement here, right? Because this is just plain wrong. And GPT-4 has the perfect answer. But here is somewhere in between. It isn't quite sure. But pretty happy with how this turned out. And yeah, I'm gonna do some more testing on this. But my kind of initial thought is that this worked. Remember, we only did 170 examples with the synthetic data set. So I gotta say, I'm pretty happy with the results. I found it kind of interesting, to be honest. So I'm gonna do some more testing on this. Maybe we try something different. If you have any ideas in like the comments below of what we can test, trying to fine tune like a very narrow model on synthetic data. But I think that was all I had for now. And very interesting project. I had a lot of fun with this. I learned a lot. So like I said, if you want access to like my files here, how you can produce your own datasets, how you can fine tune it, I'm gonna leave a link in the description below so you can kind of become a member and you get access to the private GitHub so you can try this out for yourself. I might even do a more in-depth tutorial on how I did this. But anyway, hope you found this interesting. At least I did, and I learned a lot from it. So very cool stuff. Synthetic data might be the future. Just have to wait and see. Thank you for tuning in. Have a great day, and I'll see you in the next one.